Hello, YouTube. This is Umozo3. In the previous lesson, we talked more about pass by value, and we talked again about this concept that Java passes information by value rather than by reference. We saw an example where we created a variable and we passed it into a static method, a void static method, which was supposed to increment the variable or concatenate something onto the string variable. But then when we tried printing the value of the variable, we saw that there was no increment, there was no effect on it. And that's because Java just passed a copy of the variable rather than an actual reference to where it exists in memory. So what we're going to do, I created another class called Monday. We're going to be working in a similar class to the previous video, but instead of renewal, we'll be working in a class called Monday. And remember, you have to import several important classes that you want to use. So if you want to use an enumeration, you have to say import java.util.enumeration. If you want to use a queue, you either have to say import java.util.queue and import java.util.LinkedList, because we said queue is an interface, not a class that you can initialize. Or you could just import java.util.concurrent.concurrentLinkedQueue, right? If you want to use the list iterator, you have to say import java.util.listIterator. But we have a very simple class here. We declare a private instance variable. It's a char data type, so a character. Remember, a primitive character like the $sign or the lowercase r or the number 9 or the capital O. These are examples of characters, right? Characters like on your keyboard. And we talked about how different characters have different ASCII codes, right? So the lowercase n has ASCII code 110. The n square bracket has ASCII code 93. So hopefully that's clear to you, but you could look that up on any of a number of different websites. So the constructor Monday of char c, this time my character equals c. So it just assigns the my character instance variable to the parameter passed in. And then we have an example of a method that looks like it should be successful, but according to the pass by value theory, it fails. So public static void next character fail, and it passes in a character and a Boolean, right? But it just says c plus equals 1. So we said in a previous video that if you increment a character, basically that has the effect of returning a character with that higher ASCII value, right? So if you take a lowercase p and you add 1 to it, basically that's going to give you a lowercase q, because the lowercase q has a 1 higher ASCII value than the lowercase p, right? We're talking about now 113 instead of 112. So hopefully that's clear to you, and we can just go back and forth between code that I wrote and the output here. But anyway, this would fail because, like we said, with pass by value, it would just be incremented locally. And then once you leave the method, the information about this plus equals 1 is lost. So that's what we're going to see an example of, right? So then if we say char my letter equals b, the letter b, capital B, system.out.println of my letter, and you just get b. Monday.next character fail of my letter with true. So it doesn't matter what the Boolean b is, but it should increment b, capital B, to capital C, because capital C has an ASCII code 1 higher than capital B. So then if you say system.out.println of my letter, it still says capital B. So we talked about 3 solutions. That one is to use an instance variable. So now let's reassign my letter to lowercase u, system.out.println of my letter. We just get lowercase u on the console. Monday m1 equals new Monday of my letter, Monday.next character of m1. So let's think about what the next character static method does belonging to the Monday class that accepts an instance of the Monday class. Well, it simply increments the value of the my character instance variable for the parameter passed in by 1, right? It increments that my character instance variable. So it would basically reassign that instance variable to be 1, to be the character with 1 ASCII code higher, with the character encoding is 1 number higher, right? And so then if you said Monday.next character of m1 and then system.out.println of m1.myCharacter, then you would get lowercase v instead of lowercase u. And we talked in previous videos about how it's good etiquette to have private instance variables and public getter methods. But here we're just calling directly on the private instance variable, and that's okay because we're working in the Monday class, and that's where the private instance variable is defined. But usually it's good etiquette to have a getter method, okay? And then you could say my letter equals capital P, system.out.println of my letter, so you just get capital P, but then system.out.println of next character of my letter. So let's figure out what the overloaded next character method does that accepts a character, right? That accepts just a simple primitive character instead of an instance of the Monday class. So with this overloaded method, we return a new character. In particular, we return the character that's like the next character, right? The one with 1 higher character ASCII encoding. Because with the implicit casting, the c plus 1 is not a character, it's an int. So then you have to convert that new int back to a character. We talked about implicit casting, about how an int how a character is converted into an int. So that's why we need this explicit conversion back to a character, but that would have the effect of incrementing the P to a Q. And that's why you can get the Q printed on the console. And my letter equals the digit 3, right? The character 3. System.out.println of my letter, but then you have basically a character array with one element in it, just the my letter. And you could say Monday.next character of tiny array. So let's think about what the next character static method does that accepts an array of characters. Well, it says my array of 0 plus equals 1. And so then that increments 3 to 4, right? If you say for each character y and tiny array, system.out.println of y. So you just get that one element. You would get 4 because 3 was incremented to 4 successfully. And then for the rest of this video, we can basically go ahead and review some of the things that we were talking about with iterators and data structures, right? So hopefully we're a little ahead of schedule. So if anything, hopefully we can make this a 20-minute video and not shorter. But anyway, we talked a lot about data structures in previous videos, right? We first talked about an array list, which is a collection. It's a growable collection of elements where the elements have index positions, right? That's how we think of the elements, as having index positions. So it's really good at getting elements at index positions and modifying the elements at particular index positions. But then we talked about a linked list, and a linked list is a fundamentally different type of list. It's not an array list. With a linked list, elements point to the next element, right? It still has a similar collection of methods, but something like list.get of 83 will be a lot slower for a linked list than for an array list. But if you're trying to add an element to the beginning of a linked list, that would have much better time complexity. It would be a lot quicker than if you were trying to add an element to the beginning of an array list, right? And then we talked about a stack, which is a last in, first out data structure, kind of like a stack of dinner plates. You could look at the API to remind yourself of the methods that are available to a stack. And then we talked about a queue, right? And we said a queue is a first in, first out data structure where we remove elements from the beginning of the queue and add them to the end of the queue, like people waiting in a supermarket. And then we talked basically about a set, and we said that a set only has unique elements, no duplicates. And we think about a collection of unordered elements, right? And then we talked about a hash map or a dictionary, which is a collection of key value pairs where the keys have to be unique, but the values in the dictionary don't have to be unique. And then we talked about legacy or alternative data structures, right? So the vector is just like an array list, but it also gets an enumeration, which is like a weaker iterator, okay? And then a hash table is just like a hash map, but it also gets an enumeration, which is like a weaker iterator. And then we talked about a concurrent linked queue, which is just like a queue. The only difference is what you import and how you create it, okay? And we talked about a linked hash set, which is just like a hash set. The only difference is it's a subclass, right? It's slightly longer to write the class name. And we talked about a linked hash map, which is just like a hash map. The only difference is it's a subclass, so it takes a little longer to write the class name. And then we talked about a concurrent hash map, which is just like a hash table, right? Because it has an enumeration on the values. So the concurrent hash map is slightly more similar to a hash table than it is to a hash map because it has an enumeration. But other than that, they have very similar methods, right? And they're very, very similar data structures. So you have two array lists, one linked list, one stack, two queues, two sets, and 4 dictionaries. So 32 combinations among those 6 essential architectures. So vector of type Monday, my characters equals new vector of type Monday. Monday S1 equals new Monday of the character 8. S2 equals new Monday of the character R. S3 equals new Monday of the character lowercase m. And then my characters dot add of S1, my characters dot add of S2, and then Boolean P equals my characters dot add of S3. So if you had to remind yourself, you could go back and look at the API, the Java API for the vector class, and you could see that the add method, not only is it capable of adding an element to the end of a vector, but it actually returns true. So the value of the P Boolean variable would be true after this operation. You look at the API if you don't remember that. And then we can go ahead and also have an enumeration. I guess so you could have an enumeration on the vector. So enumeration of type Monday, character parse equals my characters dot elements, and then int r equals 0. While P, remember P is a true Boolean. It's always going to be a true Boolean. So how are we going to break out of this loop? Well, presumably we'll need a break statement. So if r is equal to my characters dot size, which is right now 3, break. Otherwise, Monday current element equals character parse dot next element, right? These are the two methods that you have available to an enumeration, or has more elements and next element. Here we're not even using has more elements, so we're going to have to keep up with another way to make sure that there is a next element. And here, that's kind of seems like what this break architecture is doing, right? But you say Monday current element equals character parse.next element, system.out.println of current element. So what is the toString method? What does it mean to print an instance of the Monday class? So if you scroll up, I have a public string toString, and it says return this character is concatenated with character.toString of this.myCharacter. So if you go back to the character wrapper class, if you go back to the API for the character class that we talked about, you can see that there's a static method that accepts a character primitive and returns the string object representing a specified character. So the result is a string of length 1 consisting solely of the specified character. Okay, so that's what would be returned. So this character is A, this character is capital R, this character is lowercase m, right? Because those are the characters that we added, right? A, R, and M, and that's the string representation of a Monday object, right? We're just going to use an enumeration to enumerate through the elements in the vector using the toString method. But we have to increment R by 1 every time so that eventually we break out of the loop. And then we could have an example of a queue. So concurrent linked queue of type string, my queue equals new concurrent linked queue of type string. Okay, and then we could say my queue.add of driving, my queue.add of skiing, my queue.add of tennis, my queue.add of golf. So again, with queues, you have to think about a data structure where the first people to come into the queue are the first people to come out of the queue. So driving was first in line, and then skiing showed up, and then Dennis showed up, and then golf showed up. So the first thing that we're going to do is driving, right? That's the first thing. That's the thing at the beginning of the queue, rather than with a stack where the first thing that we would remove is golf, right? If we were pushing elements onto the top of the stack, but this is a queue, which is the opposite. So system.out.println of my queue.contains of 10 concatenated with nis, well, that would be true, right? Because tennis is in the queue. But system.out.println of my queue.remove of horse, well, that would be false, right? Because if you go ahead and look in the documentation for the concurrent linked queue class, you can see that the remove method not only removes an instance of the specified element from the queue, but it also returns a Boolean. And the Boolean is true if the queue is changed as a result of the call. But since we didn't have horse in the queue, the queue wasn't changed. So that's why it would be true for tennis, but false for horse. But tennis is removed. Iterator of type string qparse equals my queue.iterator, while qparse.hasNext system.out.println of qparse.next. So a very straightforward way to print the elements in the queue one at a time. So driving, skiing, tennis, golf, right? That's very straightforward. And then system.out.println of my queue.isEmpty and my queue.size equals 0 will not only is it not the case that both of those Booleans are true, but neither of them is true, right? Because we still have all the elements in the queue. We didn't remove any of them. We could have used the iterator to remove elements from the queue, but we didn't. We didn't call remove. So no, the queue's not empty, and no, the size is not 0 either, right? But then, so that's why you would get false for that. But that's an example of a concurrent linked queue. Okay, and then we can have another example. And so I wanted to do another example with list iterators to make sure we were doing enough justice to that topic. So we said that with these data structures, we have different availability of iterators, right? So we said with an iterator, you can see if there's a next element, you can get the next element, and then you can optionally remove the element that was just referred to with next, okay? With an enumeration, you can do all those things except remove. So you could see if there's more elements, and then you could get the next element if there is one, but they're longer method names and no remove method. And then we talked about a list iterator. We said a list iterator is stronger than an iterator because a list iterator, not only can it go backwards instead of forwards, but it can also add elements to the underlying collection instead of just removing them. So I wanted to go ahead and show you an example of that in this video. So we're going to review linked lists. Remember, linked lists and array lists are not the same thing. Array lists and vectors are a lot more similar than array lists and vectors are. Okay, because array lists and vectors are a lot more similar than array lists and linked lists are, because linked lists don't really have index positions. You have to think of nodes where each node points to the next node in the linked list. But we're going to say linked list of type double, my nodes, equals new linked list of type double. And then we're going to say my nodes.add of 3.2, my nodes.add of 9.1, my nodes.add of 13.8, my nodes.add of 81.1, my nodes.add of 0, 5.2. So then if you forgot what it means for the add method to accept 2 inputs instead of just 1, you could go ahead and look at the API for the method works, right? This is an overloaded method that belongs to the linked list class. And if you just pass in 1 input, then it adds that element to the end of the linked list, right? And it returns true. It's a Boolean method. But if you specify two inputs to the add method, if you specify an index position and an element, it's just a void method. So it doesn't return true, but it's just a void method, and it inserts the specified element at the specified position of the list. And it moves all subsequent elements one index position to the right. And we talked about how that works for lists, right? For array lists and linked lists and vectors, right? And so so that's how that works. So you would basically add it to index position 0. So 5.2 would come to the beginning of the linked list. And then you could say list iterator of type double, node parse equals my nodes.list iterator. And then int running total equals 0. For int k equals 0, k is less than my nodes.size, k plus equals 1, double current element equals node parse.next. So we're going to use current element to refer to each of the elements in the linked list as the node parse list iterator goes through them, iterates through them, right? But you would assign that to current element each time. And then running total plus equals current element dot int value. So remember, current element is an instance of the double class. And the double class provides an instance method called double value, right? And you call Java API. And remember, the int value, we don't have to overburden the point, but it just returns the integer of that double, right? So if you had double A equals new double of 8.3, the int 8, right? That's the method right here. So it returns the value of this double as an int by casting the type int. It's pretty straightforward. But you would just have a running total, right? So you would have 5 and then 18 and then 17, right? Because it would be 5, right? And then plus 3 is 18. 5 plus 3 is 8. Plus 9 is 17. Plus 13 is 30, plus 81 is 111. So it gives us that running total as we iterate through the linked list, right? And then so that was using the list iterator to iterate forwards through the linked list. But with array lists and linked lists and vectors, and especially with stacks, it's helpful to be able to iterate through it in the reverse direction, because with stacks, the order that we would remove elements or see elements in the stack is the opposite in the order in which they were added. So it'd be nice to be able to go through the collection previously rather than like forward to backward, backward to forward. So let's say system.out.println of going backwards and adding something. So what we're going to do is we're going to use the list iterator to add an element to the underlying collection. Remember, that's something that we can do with list iterators that we can't do with iterators. So it's a void method, and it says add of something. So inserts the specified element into the list. It's an optional operation, but wherever the cursor position currently is on that linked list, that's where the element is going to be added. So you say node parse to add of 305.2. And right now, after running this for loop, node parse made it to the end of the linked list. So right now, node parse is looking at the very end of the linked list. It's looking at index position, I guess, 5, right? It would be at like after index position 4. That's where it's at. And so then if you say node parse add of 305.2, the 305.2 is going to come onto the end of the linked list. And then we're going to say for each double item in my nodes, system.out.println of node parse.previous. Okay, we could have, I guess, said just system.out.println of item, but what we're doing here instead is we're going through it in reverse direction. So the node parse made it to the end of the linked list, and now we're going to go back to the beginning of the linked list, one element at a time. So we're going to see those doubles in the my nodes linked list, but in reverse order. So it's going to be 305.2 because we use the list iterator to add that element where the cursor position was at when we called it, and then 81.1, and then 13.8, and then 9.1, and then 3.2, and then 5.2, because we added 5.2 to index position 0. So that's basically how iterators and list iterators and enumerations work on array lists, linked lists, stacks, queues, hash sets, and hash maps, and also the 6 alternative or legacy data structures. And also another example, another chance to see past 5 values. So hopefully that content is clear and interesting to you. From UMills03, thanks for watching, and please subscribe.